Hey there, 6th grade. So our first unit that we just ended was all about multiplying and dividing decimals, and this next unit that we'll start with this video is about multiplying and dividing fractions. And so this first lesson here, we're going to go back to estimating and learning how to estimate products of fractions. And we're going to start with this short example here. So it says a wildlife preserve has 20 tigers, and about 1/3 of them are male. About how many of the tigers are male? So again, anytime you see that word about, that usually means we're going to be either estimating or rounding our answers. And for multiplying fractions, this is how we're going to do that. So first of all, it tells us 1/3 of the tigers are male. And whenever you see that word of in a word problem, it usually means multiply, especially when you're dealing with fraction problems. So we're going to make this, the multiplication problem, 1/3 times 20, since there are 20 total tigers. And in order to estimate this, the first thing I'm going to do is look at the denominator of our fraction. The denominator of our fraction is 3. And so then what I'm going to do in step 2 is find the multiple of my denominator that is closest to the whole number that I'm multiplying by. So here's what that means. I'm multiplying this fraction 1/3 by 20. 20 is not a multiple of 3. But 21 is a multiple of 3, okay, and 21 is pretty close to 20, so I'm going to, in order to estimate this answer, change my 20 to a 21, okay? Now, to multiply this fraction 1/3 times 21, I'm going to draw what's called a bar diagram, and I want to see this anytime you're doing these kind of fraction multiplication problems on your homework. When we're estimating these, I want us to get a visual picture of what it really means to take 1/3 times 21. So what we're going to do is we're going to draw a bar that represents 21. And because our fraction is 1/3, I'm going to split this bar into thirds. Okay, so I'm going to make 3 somewhat equal sections here. Again, this whole bar represents the number 21, and if it's split into 3 equal sections, then that means that there are 7 parts in each section, okay, and that's what step 4 here is talking about. If my entire bar is 21, then one section of it is 7, another section is 7, and a third section is 7. 7 plus 7 plus 7 is 21. So now, since we are supposed to be finding 1/3 of the number of tigers, I'm going to shade 1/3 of this bar. And that means I've shaded 7, okay, total tigers, you can imagine. Okay, 7 total tigers is what I've shaded here. So the estimate to my multiplication problem here, 1/3 times 20, is about 7. Okay, let's practice this some more, going on to the next few examples. So now I have the problem 1/4 times 17. And so my first step again is to look at my denominator. My denominator is 4, and I want to change my whole number here to a multiple of 4 that is still close to 17. So I will probably change this to a 16. 16 is a multiple of 4, and 16 is pretty close to 17. And now I'm going to draw a bar diagram that represents the number 16. Okay, so this is 16 here, and I want to divide this bar diagram into fourths, so 4 equal pieces. There's 1, 2, 3, and 4. If these are 4 equal pieces and my total amount is 16, that means they each need to have 4 in them. 4 plus 4 plus 4 plus 4 is 16. I'm only taking 1/4 of this bar diagram here. My fraction is 1/4, so I'm going to shade one piece of this, 1/4, and so my answer to this problem is 4. 1/4 times 17 is about 4. Problem 2, I have 2/5 times 34. Again, I'm looking at my denominator. My denominator is 5. I want to change my 34 into a multiple of 5 that's still close to 34. Well, all multiples of 5 end in 0 or 5, so I could change that to 35. So now I'll draw a bar diagram that represents 35. The denominator of my fraction was 5, so I'm going to make this bar diagram divide it into fifths. So there's 1, 2, 3, 4, and 5 pieces. If this 35 is split into fifths, that means each piece has 7 in it. 7 plus 7 plus 7 plus 7 plus 7 is 35. And now, my fraction here was 2 fifths, so I'm taking 2 fifths of this bar, or 2 equal pieces. So there's one piece, and there's my second piece. So I have 7 plus 7 more, so my answer is 14. So 2 fifths times 34 is about 14. Okay, and then number 3, I have 3 sevenths times 27. Again, looking at my denominator, which is 7, I need to think of a multiple that's close to 27, a multiple of 7, and I will probably use 28 for this one. So 3 sevenths times 28, I can show that by drawing a bar diagram that represents 28. And I'm going to split this into 7 equal pieces. So there's 1, 2, 3, 4, 5, 6, and 7. And if this is 7 pieces, my whole number is 28. That means each of these pieces has to have 4 in it. Okay, so now I'm taking 3 sevenths of 28. So I'm going to shade 3 pieces. There's 1, there's 2, there's 3. I have 4, 4, and 4. 4 plus 4 plus 4 is 12. So my estimate here, 3 sevenths times 27, is about 12. Okay, moving on to estimating products of fractions or mixed numbers. So this is when we're multiplying a fraction by another fraction or by a mixed number. So when you're estimating the product of 2 or more fractions, what we're going to do is we're going to round each fraction to one of the following 3 numbers. Either 0, 1/2, or 1, depending on what the fraction is closest to. So let's say we're estimating the problem 1/3 times 7/9. Okay, well, I can visualize this kind of on a number line here. On my number line here, I'm going to mark a place for 0 and for 1. And if 0 is here and 1 is here, 1/2 is going to be in the middle. And so now, just to get a picture of what 1/3 and 7/9 are closer to, 1/3 would be about 1/3 of the way from 0 to 1. So it would be about right here. And then 7/9 would be, again, 7/9 of the way to 1. So it'd be over halfway to 1. It'd be about right here. So you can kind of see from this number line that 1/3 is closest to 1/2 of these 3 numbers here. 1/3 is closest to 1/2, and 7/9 is closest to 1. So I can estimate my answer to this problem by making 1/3 1/2, and by making 7/9 1. 1/2 times 1 is going to be about 1/2. When we're estimating the product of 2 mixed numbers, then we're just going to change each of the mixed numbers to the nearest whole number. So if I had the problem 14 and 5/6 times 6 and 1/8, well, 14 and 5/6 is really close to the number 15, and 6 and 1/8 we can round down and just say that's about 6. 15 times 6 is about 90, so I might use 90 as an estimate for this problem. Okay, so let's try this with a few more examples. Number 4 here, I have 1/9 times 7/8. So let's visualize where 1/9 and 7/8 are on a number line. So if 0 is here and 1 is here, again 1/2 would be right in the middle. 1/9 is not very far away from 0. It's about 1/9 of the way between 0 and 1, so it's about right here. And 7/8 is about 7/8 of the way from 0 to 1, so it's about right here. So you can see from this that 1/9 is closest of these 3 numbers here to 0, and 7/8 is closest to 1. So this would be, a good estimate for this would be 0 times 1, which is 0. So we'd say this one is about 0. Number 5, I have 4/5 times 6/13. So again, we'll visualize with the number line what these fractions are closest to. Okay, 4/5 is over halfway, the distance from 0 to 1. It's going to be about right here. 6/13 is a little under halfway the distance from 0 to 1, but it's really close to halfway. It's about right here. Okay, so you can see from this that 4/5 is a little bit closer to 1. 6/13 is closest to 1/2. And 1 times 1/2 is, we know, 1/2. So this estimate would be about 1/2. Okay, and then number 8, we have two mixed numbers that we're multiplying together. 2 and 6/7 times 4 and 1/9. Well, 6/7 is really close to 1, so 2 and 6/7 would be closer to 3. 4 and 1/9 would be closest to 4. If I was going to estimate these to their nearest whole number, 3 times 4 we know is 12, so a good estimate for this would be about 12. Okay, so when you're doing your homework over this section, remember that you are estimating, so some of your answers may be a little bit different than what I have on the answer sheet, but they shouldn't be too far off. If you have any questions over this video, be sure you ask those in class the next time I see you, and until then, have a nice day. You're all wonderful people. Take care.